Hi, welcome. This is a lesson on the properties of chords and tangents for circles. So let's first talk about some definitions. Um, a tangent, first off, a tangent for a circle is a line that touches the circle at exactly one point. And so that point, this line will say, this line T is tangent to this circle, we'll call circle C. And the radius of that circle, there's the radius, and the point where they are tangent, those two lines, the radius and the tangent line, are perpendicular to each other. And so that's one of the properties of tangents, is that they are tangent to each other. Now, another thing, or that they're at right angles, excuse me. The other thing is that if there's two lines tangent to a circle from the same point, so if I draw another tangent line out here and it's tangent at that point, so the radius that meets at that point, also at right angles, that would mean that these points, that this distance here, if we call this x, the length of that to that point of tangency from the point where they are having common, this distance over here would be the same. Move that t over here. And so this distance would also be x. Whatever those distances are, they will be the same if they're tangent to the circle from the same point. Let's talk about chord. What's a chord? So a chord is a line that connects two parts of a circle. So that is a chord. And the most famous of all of the chords is this chord that goes through the center. That is a chord, but it's more commonly called the diameter. But because it connects two parts of the circle, then it is also a chord. And sometimes we have chords that intersect, like this line and this line here. Those are two chords that intersect, and what happens is that there's a certain property of those chords. Let's say this was 3, and over here, let's say this is 4. So if the distance from here where they intersect to the point where they touch through the circle is 4 units, and over here is 3 units, then over here I could say maybe this is 2. This then over here would be 6. And the reason I know that is because 4 times 3 is equal to 2 times 6. They're both equal to 12. And that's another property of intersecting chords, is that the segments that are formed by those intersecting chords, when you multiply them together, this 4 times this 3 is equal to this 2 times this 6. And so they would both be equal to 12. And that's one of the properties of intersecting chords for their segments. But another thing is that this angle, if we just call that angle theta, the arc over here, let's call its angle x degrees, and this arc over here, let's call that y degrees. If I take x degrees of the one arc plus y degrees of the other arc, and then I divide it by 2, I would get theta. Or another way to think about that is 2 times theta would be equal to x plus y. And so we're going to use these properties in a number of different ways. So let's take a look at this. Go straight to the notes. You also have these properties listed out in a more formal way in the handout that you received, but it's also right here. And so you can come back to this point and review. But here's our notes. It says in the diagram below, segment AC is tangent to the circle with the center at point O. Point B, where AC intersects circle O, is called the point of tangency. So AC is perpendicular to radius OB. Now, what that means is then this is a 90-degree angle. This is 90 degrees here. On the other side would also be 90 degrees. So the notation for that is that AC is perpendicular to OB. That's how we would read this. Segment AC is perpendicular to segment OB. Then the measure of angle ABO, we can read from the diagram, is 28 degrees. So then when we want to know, well, what is X? Well, I know that if this is a right angle, this right here is also a right angle. It's also 90 degrees, which means that, I'm going to go down here, X plus 28 degrees is equal to 90 degrees. Look at that again here. So let's put a little color to that. Angle X here plus this angle of 28 degrees together would be 90 degrees. So 28 degrees plus X degrees is equal to the 90-degree angle. So then it's just a simple problem to solve this equation. Subtract 28 degrees from both sides. And X then would be equal to 62. So 62 degrees, that would be our value here for X. And that's a simple way that we could talk about how we might use a tangent line in a problem like this, just recognizing that if the tangent line and the radius are perpendicular to each other, they form a right angle. All right, let's look at number 2 here. For the figure at the right, find the measure of angle ABD. ABD. Now, we've got 65 degrees here, and we've got 37 degrees here. B, we cannot assume is at the center. It doesn't appear to be at the center, and they didn't say it was at the center. If it was at the center, then we could just look at that and say, well, the central angle would be the same as the arc measure. It would be 65 degrees. But we don't know that. What we do know is that because these are intersecting chords, this 65 degrees and this 37 degrees, if we add them together, 65 degrees plus 37 degrees, and then divide them by 2, it will give us the measure of either angle ABD or EBC, which are the same. And so we go ahead and do that. 65 plus 37 would be 102. And 102 divided by 2 would be 51 degrees. And so this is 51 degrees. That's the measure of angle ABD is 51 degrees. The measure of angle CBD, because this is 180 degrees, I can then just take 180 degrees and subtract the 51. And that would be 129. Yep. So 129 degrees. All right, another example here. It says in the circle at the right, segment AB and segment CD are chords intersecting at E. If AE equals 5, let's go ahead and label that. AE equals 5, this is 5. BE equals 9, BE equals 9. And CE equals 8, CE equals 8. Then DE equals what? So we'll go ahead and use a variable, we'll call this X. And then it's just like we talked about just a moment ago, 8 times X will be equal to 5 times 9. And 8 times X is equal to 5 times 9, which would be 45. And X, then we divide both sides by 8. And X then is 45 eighths. And that you can't simplify it. So you could leave that as an improper fraction, Or you can write that as a mixed number, and it would go in there 5 times, it goes into 45 5 times with 5/8, and you can convert that into a decimal, or you can just leave it as an improper fraction. So 45/8, or 5 5/8, or then as a decimal, and I believe that would be about 5.625. All right. On this error analysis problem, let's see what they've done here. They've said that we've got this angle is 60 degrees. And in this problem, I know this arc measure and I know this arc measure, and if I add those two and divide by 2, I should get 60. So let's use the space over here. If I took 55 degrees and I added it to 5x plus 15 degrees and then divided that by 2, I would get 60 degrees. So what they have done here incorrectly is that they've assumed that if I could take 5x plus 15 and then just add these two numbers, 55 and 60, and it doesn't work like that. So I can get rid of this 2 by multiplying both sides by 2. So if I multiply here by 2 and over here by 2, then I've got 55 plus 5x plus 15 is equal to 120. And then I can combine these like terms. 55 plus 15 would give me 70. So I've got 5x plus 70 equals 120. Then I subtract 70 from both sides. 5x then is equal to 50. And then I divide by 5. X then is equal to 10. And so that would be the correct solution to this problem. You add the two arc measures, you divide by 2, and that will give you either that this is 60 or this is 60. They both will be the same. They'll be equal. These are what are called vertical angles, and they are always equal. All right. You practice your problems. I do want to give you kind of a heads up on one of the problems you're just going to see in the homework. Let's look at this problem right here. Now, these lines are all tangent to the circle, and they're all tangent from the same point. And so I know that this segment and this segment are equal, but that doesn't help me much because this one has a z and this one has an x. So I can go over here and think, well, this segment here and this segment here are also equal because they're tangent from the same point, but this has a y and this one has an x. That doesn't help me either. So then I go over here, this segment and this segment are equal, and they both have an x. So that's where I'm going to start. And I would set up the equation just like this. I would say 3x minus 4 is equal to 4x minus 12. You're going to go through the process of finding out what x equals. X equals whatever it equals. And once you know what x equals, you'll know what it equals there and there. But you also know what x equals there and there. And so you can substitute that whatever this value is. Let's use a different color for that. Whatever we come up with x being here, it's going to be true here, 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 and here. And so then if I know what x is here, I know what this segment is, and z would be the same. And once I know what x is here, I can divide it by 2, then add 3, and y will be the same. And so that way I can go through and find out what all of those equal. So go through these problems, give it a try, see what you can do. Practice, work together. You got this.